Mission Atlantic, to ensure a sustainable future for the Atlantic Ocean. Integrated Ecosystem Assessment, or IEA, is a holistic approach to managing ecosystems by evaluating the cumulative impacts of natural variation and human activities. It follows an IEA loop that starts with scoping the system, together with stakeholders developing indicators, analysing the risks from and to different parts of the system, testing potential future scenarios under natural and anthropogenic change, and refine focuses on revising and improving the assessments based on the outcomes and insights gained from earlier stages in the cycle. This process helps balance trade-offs between ecological health, social well-being, and economic viability, ensuring sustainable use and conservation of ecosystem services. The risk analyses phase identifies and evaluates potential threats, quantifying their likelihood and impact. Risk analyses pinpoint parts of the system that require attention today, but also in various uncertain futures, ensuring long-term sustainability and resilience. In this video, we explore an approach to build up a comprehensive picture of a socio-ecological system and how to boil it down to the components of highest priority. Our guide, Debbi, introduces the ODEMM approach to structuring socio-ecological systems and the steps involved with quantifying the risks to different components of the ecosystem from various human activities. Using an example from Mission Atlantic, we see how an uninterpretable system can be reduced to a small number of activities and pressures associated with producing the highest risk to different ecosystem components. Debbi provides a critical analysis of this approach, accompanied with some tips and guides for anyone starting out on their own application of this methodology.
Hello, my name is Debbi Pedreschi and I work for the Marine Institute in Ireland. Today I'm speaking to you on behalf of the Mission Atlantic project about the scoping methods we use for our integrated ecosystem assessments. Integrated Ecosystem Assessment, or IEA, is an integrated assessment of the whole ecosystem. Therefore, it's a tool for ecosystem-based management. When we're talking about ecosystem-based management, we need to consider all of the different elements and aspects of the ecosystem. So we're looking at each of the individual species and how they interact with each other, their habitats and how they're interacted with as well, and the full range of human activities and sectors and what pressures they may create that may affect the marine environment, but also how we benefit with goods and services from those interactions. So we take a socio-ecological systems view to integrated ecosystem assessment to support ecosystem-based management. IEA is an iterative process involving a series of steps that you can see here and learn about in this series of videos. But for today, we're focused on the first step, which is the scoping step. And within this step, we identify what are the relevant components or elements that will be included in our assessment. And this goes hand in hand with the discussion of the scale, because the scale at which your assessment is carried out will determine which of the management objectives are relevant, which ecosystem components should be included, and what human activities are taking place there. In terms of methods, our scoping methods start off as largely qualitative. The reason for this is because we don't have perfect data available to us, and in order to look at the wide range of components that we're assessing at this stage, we need to be able to include everything, and without that data, we can't do it in quantitative ways. But using qualitative and semi-quantitative approaches allows us to carry out a prioritization exercise where we can assess where we should be focusing our efforts, where is the highest risk within the system, and from this filter down from a wide range of components that we're accounting for into a smaller number of elements that we can assess using more quantitative methods such as ecological modelling. Within Mission Atlantic, we have carried out both risk and vulnerability assessments, and the method underpinning this has been adapted from a previously funded European project called ODEMM. It's Options for Delivering Ecosystem-Based Marine Management. It's a DIPSR style approach, which is a driver, pressure, state, impact, response type of approach, by which we mean linkage chains are established and reviewed and scored. There are many variations for what you include in your assessment and how complex it is or it isn't, and it depends on what your needs are for your purposes. The approach that we've taken within this project is currently being used and is in line with the ICES approach and is also very similar to what is used in OSPAR. The process is through an expert panel review and assessment, so using expert judgment, sometimes including stakeholders at that point as well. It's supported by data where we have it, which may come from monitoring data, may come from spatial mapping data, or from other elements of the project, so we may have trend information available to us. And even if stakeholders aren't involved in those panels, they are involved in the process because we take our outputs and our list of sectors and pressures, etc., to the stakeholders to ground truth and identify what we might be missing and to ensure that what we're doing reflects their understanding of the system. The outcomes that we intend from this are to identify those relevant sectors, pressures, and ecosystem components, to establish the relationships between them, so to identify which sectors create which pressures and which ecosystem components are affected by them, and to assign scores to each one of those linkage chains or pressure pathways. From this, we can then identify where the greatest risks or vulnerabilities in our system are, and also identify where we have data gaps, because of course when we're carrying out this panel assessment, we mentioned that we support it with data where we can. The goals ultimately are to be able to carry out this prioritization exercise so that we can highlight areas for management action and ultimately distill a very complex system into some interpretable and actionable outcomes and outputs. Within Mission Atlantic, we have taken the two core components of the ODEMM assessment separately. So the impact risk elements have contributed to our risk assessment, whereas the recovery lag aspects feed into the vulnerability assessment. The focus of today is on the risk assessment aspects because that is what we used for our scoping exercises, whereas the recovery lag components, such as the persistence and resilience, feed into the vulnerability assessment, which you will learn more about in one of our other videos. In terms of the risk assessment, we score 3 criteria. We assess the spatial extent or the spatial overlap between the component and the sector or pressure that it creates, the frequency occurrence of that pressure and impact, and the degree of impact. So how bad is it, its severity and magnitude. No matter whether we're looking at the vulnerability assessment or the risk assessment, there is a 3-step process underpinning it of identifying the linkages, scoring those linkages, and then analysing the outcomes. The first step in this process is to build your linkage assessment. And in order to do that, you need to identify what are your relevant sectors, pressures, and ecosystem components or ecological characteristics within your study area. There are multiple places that you can get these component lists from, either from the Mission Atlantic project, the ODEMM project, Aquacross project, and so on, or you can base them on things like the Marine Strategy Directive components. It is important to note that we are looking for direct effects only within this assessment, and we're focused on current status assessment because we want to know where the risk in our system right now is. Once we have these lists, we can then build our linkage framework. We do this through a simple matrix approach where we have our list of sectors on one axis and pressures on the other, and we simply put an X in the box to indicate where an interaction occurs. We then repeat it, looking at which pressures affect which ecosystem components, and once we have this information, we can build our linkage chains, so which sectors create which pressures affecting which ecosystem components. We operate using the precautionary principle, so if in doubt, keep it in, and we can assess it further at the scoring stage. Once we have all these connections identified, we can then illustrate our linkage framework with a hirandogram such as this, where we have all the sectors across the top, all of the pressures across the middle, and all the ecosystem components across the bottom. However, this is quite difficult to decipher, and so we need additional methods and analyses to be able to understand it better. We can use metrics like proportional connectance to give us some insight. For example, the ranked bar chart indicates that nuclear has the lowest connectance among our network, which is illustrated in the filtered hirandogram, in comparison to something like fishing, which has the highest proportional connectance. Again, you can see the difference between the two. However, while this does give us some information, it doesn't tell us how severe or the magnitude of the impacts that are coming from these. It's just how connected they are. For that reason, we need to move on to the pressure assessment, which is where we score each individual linkage chain. Within the pressure assessment, again, it's the same process for the vulnerability or the risk assessment, but here we're focusing on the risk assessment, where we look at the spatial overlap, the frequency of occurrence, and the degree of impact. For each one of these categories, there are criteria on how you score them. So there's categorical scores that have associated numerical scores with them. So once we have assigned them their categorical score using our expert panels, we're then able to use the scores to carry out further analysis and to be able to identify where the majority of the risk in our system lies. As we go through assigning these scores for each of the linkage chains, we also document our level of confidence. So whether the decision for the score was based on expert opinion only, based on the peer-reviewed literature, or based on data such as monitoring programs from the region. Going through this process helps to make the decision-making process more transparent, but also helps to highlight where data gaps may exist and flag them for future research efforts. Step 3 is the analyses. It's important to note that any of the analyses or figures that we demonstrate to you today are available through our R scripts on GitHub, so check the supporting materials with this video to get the links to them. One of the key metrics that we use is relative contribution, which tells us what is the proportion or percentage of the total risk score that an individual element contributes. So the first thing that we do is look at the individual linkage chains and see which ones are contributing substantially to those risk scores. And so we filter for those that contribute 1% or more to the overall risk score. When we do that in this particular case, we see that actually all of the most impactful chains were associated with fishing. There were 4 different pressures and a number of different ecological components that were affected by those pressures. If we illustrate this, we can look at our initial rendergram that we saw earlier that has nearly 1,600 linkages and filter them down to the most impactful links, of which there are only 37, but that account for 57.6 of our total risk score. And so we can see how using this type of approach, we can start to prioritize where we may need to focus our efforts moving forward. We can use this same relative contribution metric on a sector by sector or pressure by pressure basis. And this tells us what proportion of the entire assessment each individual sector or each individual pressure is responsible for. When we do that, we can then rank them as well to identify which are our top contributing sectors or pressures. We can then combine both of these approaches in order to produce this table, which details the top 5 sectors and pressures based on both the linkages and the entire assessment. Ultimately, accounting for these top 5 sectors will mean that we account for 92% of the risk in the system, and accounting for these top 5 pressures will ensure that we cover 81% of the risk in the system. And so using these processes means that we can filter down a very complex system into something much more manageable, understandable, and this we can take forward into more quantitative analyses. This has been a relatively high-level whirlwind tour of the scoping methodology that we have used within Mission Atlantic for our IEAs. Hopefully we have learned a few things along the way that we'd like to share with you now. First of all, of course, please make sure that the tool you select is fit for your purposes. We selected this methodology because it allowed us to do relatively rapid assessments. It allowed us to carry out that prioritization. It allowed us to be comprehensive and holistic with the wide range of elements that we're able to include and to operate in both data poor and data rich environments. It is not a deep mechanistic study or approach. It also allows us, though, to replace and complement our qualitative analyses with quantitative data when we have that data available. And this area and field is evolving all the time. For example, there was a recent release of the SCARM approach, which is an evolution of the ODEMM approach and includes a method for being able to include spatial data and more mechanistic information into the ODEMM style of assessment. It's important to note that the first assessment will be really time consuming because there is an awful lot to consider. It is really helpful to use existing assessments where possible, not only because it will speed you up, but because it's much easier to review something than it is to start from scratch. And that applies both to yourselves as experts, but also to the panels or stakeholders that you may be working with. These initial scores can be assigned coarsely before reviewing and refining. So you can look at what your spatial footprint of the sector is and assign your scores based on that for the maps that you do have. And the frequency is also relatively easy to be able to assign. And then once you've done that, it's easier to be able to review that with your expert panels. Speaking of the expert panels, it is most fluid when they're able to review some sort of initial values as examples while they get to grips with the assessment, the methodology, the scoring criteria, etc., rather than having to nominate values from scratch. It is easier to react to something that you feel is wrong than it is to propose something when you're not entirely certain. It is recommended to have sub-teams for specialist areas. No individual or even single panel is able to cover the wide breadth of sectors, pressures, and components that are assessed within this process. However, if you do have sub-teams or sub-panels, it is crucial to ensure that there is a common understanding by those leading the process of the assignment criteria, of how the scores are assigned, of how the rules are applied, so that there aren't different interpretations within these different subgroups. Ideally, the same individuals would lead each one of these subgroups. And hand in hand with that point goes facilitation. It is a critical aspect of this work. There will be debates, there will be differences of opinion, there will be frustration coming from the categories being too broad for people to be able to assign them in a meaningful way. There will be all sorts of feedback that you're dealing with. As such, it's really important for you to decide ahead of time what role that you're going to have, whether as a facilitator you're going to include some guidance based off your own knowledge or the data that you have available to you, or whether you act more as an observer and just accept the values that are given to you. If you go with the latter, you must accept the values that are given to you, even if you don't particularly agree with them yourselves. So do work that out ahead of time. And be aware of pet issues, even your own ones. We all think that the thing that we work on is the most interesting and have a tendency to go into more detail there. And this can happen and derail some of the assessment panels. So just be aware of that process before you start. Some final thoughts from me. You may be thinking that this is a very subjective approach, and you're right, it is. It's largely based on expert judgments or opinions. However, documenting the decisions, the rationale for those decisions, and the confidence and data supporting it, as well as using a consensus approach among your panels, helps to minimize this subjectivity. It's also important to remember and recognize that there is currently no other way to carry out such a comprehensive, holistic and integrative review as is essential for ecosystem-based management. Limiting ourselves to those areas for which we already have data, risks limiting ourselves to assessing the risks that we already know are risks. This allows us to also identify high-risk areas that are accompanied by low knowledge or low data. And that is a dangerous combination that we do need to be aware of. Remember, it's supposed to be an evolving and iterative tool that's treated as a living document. And if it is treated that way, it becomes very useful as a rapid response tool for particular questions relating to sectors and impacts or pressures and impacts, for example. In terms of climate change, we've explicitly not included it at this point of the assessment for a couple of reasons. First of all, this is a snapshot in time, a current status assessment only. Secondly, climate change interacts with all of the elements of our assessment. It will affect the sectors, the pressures, and the ecosystem components, so it's very difficult to incorporate it in an intelligible way. So instead, we don't include it at this stage, but we do include it in the later stages of our analyses when we're looking at trends, ecosystem signals, tipping points, scenarios in our models, etc. While this approach or methodology or assessment is useful on its own and can function as an initial IEA in data poor situations, here we just use it as the first step in our IEA process and cycle. It provides us with a systematic, transparent, and fully documented approach to holistic and fully integrated ecosystem assessments. Thank you very much for your attention and interest. I hope this has been useful for you, and don't forget to check out the other videos in the series. Thank you.